Hello there, and welcome back to another episode of the Med Device Cyber Podcast. I'm your host, Trevor Slattery. Unfortunately, our co-host, Christian Espinoza, is not able to make it on this one. He's tied up with some flight delays. Today, we're going to be talking about some regulatory strategies, ensuring that we're getting quality systems put into place early and effectively in medical products, some of the common regulatory pitfalls that we see a lot of manufacturers face, and then, of course, how these regulations are going to apply to emerging technologies, namely AI and machine learning. I'm joined here by Ashkon from EnGenius Solutions. How are you doing today?
Doing well. Thanks for having me on, Trevor.
Perfect. Well, I'd love to hear a little bit about what you guys do over at EnGenius Solutions, and of course, a little bit about yourself as well.
Yeah, and the two stories obviously intertwine. My name is Ashkon Rasooli. I'm the principal and founder of EnGenius Solutions, and I have a long history of working on medical device software. I belong to a niche group of people that understand regulatory requirements and software requirements intimately because I've kind of dabbled in different roles in the software development lifecycle. I've had roles coding, testing, product managing, and then most of my career ended up being in quality management system and regulatory affairs. And all of that led me to creation of EnGenius Solutions, which is a boutique consulting firm focused on medical device software development. And so what we do is we help early to mid-sized companies with quality management system or early regulatory strategy consulting for medical device software.
Got it. So you're ensuring that they're essentially getting their ducks in a row as far as their quality system, making sure that they're identifying any of the regulatory approaches that they'll need to take, of course, the regulations that they adhere to, and kind of helping them along that path.
100%, exactly. You see, the requirements around software are basically very different from hardware. However, a lot of the regulations are old frameworks from the prehistoric old software firmware days. And so it is a whole art and its own specialty to try to have a very streamlined approach to software quality management systems. And so that's what I specialize in.
Definitely. Yeah, there's obviously a ton of complexity in software. And as the medical device landscape is evolving, pretty much everything has a software component now. Everything's connecting to the internet in one way or another. And so when we're introducing that software component, we're introducing a little bit of risk as well. And that's where it can tie into the cybersecurity side of things. Oftentimes, I feel like they're portrayed as separate problems. You have your software issues, you have your cybersecurity issues, but they're very closely related. In my mind, cybersecurity is essentially evidence of quality software. If you have secure software, you have good software. And so ensuring that you're building out your software with these considerations in mind is important, but it can be a little bit difficult. The guidance documents are complicated. There are, how many ever standards floating around that manufacturers have to try to adhere to. So I'm sure there's a lot involved with getting that QMS set up properly.
100%. I think the idea that quality management system and cybersecurity are two different entities is flawed at its core and actually results in a lot of overhead. When you think about what a quality management system is about, 1345 was based on 9001. And at the end of the day, the stated objective of a quality management system is to meet customer requirements. And when you look at the FDA regulations, they talk about safety and effectiveness. And cybersecurity fits throughout all that. Essentially, if you were actually being diligent long before the FDA got very stringent on cybersecurity, came out with all the guidances, with all the detailed requirements, if you were being diligent enough in terms of meeting your customer requirements, safety and effectiveness requirements in your QMS, you would have already done almost all of the things that the FDA is asking you to do on the cybersecurity front. And so I really see the two as one and the same.
I definitely agree. Yeah, and the whole point, the standards that we're adhering to under FDA guidance, these aren't very new standards. The FDA guidance, of course, came out in September of 2023, which is still fairly recent. But everything that it's based upon, ISO 62304, and then IEC 81001-5-1, these aren't new. These are older than the FDA pre-market guidance. UL 2900 is another example of that. And so manufacturers that had been adhering to these were already going to be compliant. I think one issue with cybersecurity, though, is it's never going to be the priority. It's essentially, an unfortunate thing that manufacturers and companies have to deal with. Nobody wants to deal with cybersecurity. It doesn't add value to the product. It simply costs. But of course, that's a flawed mindset of thinking, because if you have a product and you don't implement cybersecurity and something goes wrong with it, then you're going to be liable to a lot more than you would have been just dealing with cybersecurity in the first place. But it comes back to your original point. If you'd been adhering to these guidelines before, you'd already be fine with what the FDA is expecting. But now the FDA is just actually mandating that you adhere to these guidelines.
Yeah. And, maybe mandating is not the term they use, but it is what we see in practice in the field, right? In terms of recommended, strongly advised, and justify otherwise if for whatever reason you decide not to do it. So 100%.
Yeah, and I think even just that wording, it brings up a good point. A lot of manufacturers can get a bit caught up in the wording that the FDA uses. Another thing that we hear all the time is, well, we don't think our device is a cyber device. Because if you look at the FDA's website, you can totally understand where a manufacturer is coming from. It has a list of ands. It says you need to have a software component, and you need to be network connected, and you need to be running an operating system. And in effect, it's an or. And really, the only one that matters is the first point. Do you have software? Do you have firmware? Either one of those, you're a cyber device in the eyes of the FDA. So the wording that is used and what is seen in practice, there's a bit of a disconnect, which I think adds to the struggle that a lot of manufacturers are facing right now.
Yeah, 100%. And what happens in practice, I mentioned how QMS and cybersecurity are kind of one and the same. And you see also the same challenges across the board for QMS and cybersecurity. And, there's a list of challenges, but one of them is QMS being thought of too late, QMS engineers being brought in too late. Same happens to cybersecurity. Concretely speaking, the very first step in establishing any system, quality management system, and then the security system within it is planning. And part of planning is going to be identifying what are my requirements. With cybersecurity, there's often a misconception that it is a checklist activity to get to the market, meet the FDA's bar, and it is thought of that way. Essentially, manufacturers start thinking about it when they start thinking about the 510Ks, or, if it's a PMA, going to market essentially. But the question that should be asked, and the reality on the ground, is what is the bar I need to meet? Just like the QMS, there are three primary factors that impact the design of your QMS. They also impact the design of your cybersecurity management system. It is essentially your product design, your business model, and the location where you're planning to implement that business model. So the geographies, right? So just like we talked about FDA versus EU MDR, we talked about, does the product have software or not software? Because if it doesn't have software, something like 62304 doesn't apply. Then in the same way, your cybersecurity requirements are mandated by regulations, which everyone's aware of, things like HIPAA, things like the FDA. But then what location, what is your business model? For example, are you going to be selling into the hospital systems in the United States? High trust is a very recognized and required standard. Then you want to make sure you acknowledge that upfront. It is not so much so, let's say, in the EU. Are you going to be selling into the government? Then, NIST is often asked for. Compliance with NIST is often asked for in that business model. And then, there's the question of product design. Do you have a product with a cloud component? Is it a product that has a mobile app? Is it a product that is just firmware? Based on the answer to those questions, for example, SOC 2 may become relevant. You may decide that you need to actually do a SOC 2 compliance. And so an activity that needs to be done early on as a part of your quality planning is going to be identifying the bar you need to meet for cybersecurity.
Definitely. Yeah. The first step is what problems are we going to encounter and how are we getting across them? And even right now, everything is changing so quickly in that cybersecurity landscape. I think the community is getting a little bit wiser to it, and the regulations are catching up a bit faster than they had been previously. And we're seeing new things coming out every day. We have the Cyber Resilience Act in Europe, the Cyber Trust Mark in the US now. And those are starting to mandate, consumer electronics and even branching into government acquisition. I know that come 2027 is their target. Any consumer electronic products entering the U.S. government's anything is going to require the Cyber Trust Mark. And so all of these regulations, and of course, this is a little bit off the topic of the medical space, but it just goes to show that it's changing very quickly. You have to identify what space are you in. Even within the medical space, are you going to be subject to the Radio Equipment Directive? Are you going to be part of IVDR or MDR? What space are you going down in that path? How are you getting your product class? So it's a very complicated problem, and I think that it's a very key first step to try to figure out when you're identifying what do I need to do for the regulations, for the quality systems. But I'd be really curious to hear your thoughts on what you think are some of those really important first items that a manufacturer or an innovator should be considering as they're moving towards developing their product.
Yeah. So, as a very first point, I did mention, business model, product design, location, kind of your customer profile, who you're going to be selling to. And that, kind of helps identify the cybersecurity requirements that you can successfully go to market with. Now, when you look at the different frameworks that are out there, you may identify multiple that you need to comply with. There's, the regulations, the privacy regulations, the security regulations, standards, the total life cycle standard, 81001 that you mentioned. But you will find that there's a lot of overlap across the security standards. There's just basically marginal work additional for compliance, but also just for the auditing and certification of it. And so at the minimum, I would make sure that there's a risk management mentality across the team. I have a manifesto for EnGenius Solutions that guides every single service that we do. It's called the non-BS manifesto. Applies across the QMS, and the BS is kind of a nod to FDA's least burdensome guidance. So the BS is really burdensome. But there's 4 principles modeled after the Agile manifesto. One of them is talking about culture over mandate. And it is extremely important for a medical device manufacturer to establish a culture of quality, which includes cybersecurity, right? You need to have a team that understands that cybersecurity for a medical device is of utmost importance because, and to your point, this is not just a medical device thing. We are a safety critical industry. As a safety critical industry, a cybersecurity failure could also be a safety failure. And this is not necessarily attackers compromising assets, gaining access to assets. This could simply be attackers bringing down safety critical equipment that was necessary to deliver care. So in our industry, your device not working, delayed treatment is more than just lost revenue. It translates to actual patient harm. And so for everyone to treat cybersecurity with that urgency, with a risk management mindset is the very first step. Obviously, there's deliverables, there's activities you got to go through, there's the plan and the software architecture and the SBOM and the pen testing and all that. But that all ends up only being effective if you've got that culture in the team kind of like ingrained, because, a checklist document is really easy to generate and it is effective. It is extremely ineffective.
Right. And I feel like that was an approach that a lot of manufacturers were taking before the current FDA guidance dictated that there should be a different change. It was just more of a tick the boxes, we have a little Excel sheet. Do we have passwords on our devices? Great, moving on. And I think that's, it's like you said, it's a very dangerous mentality. Obviously, attackers are evolving really fast, and so defenders have to evolve faster. I know a very hot topic in cybersecurity is the whole concept of ransomware. That obviously is one of the big things that gets mainstream attention with the oil pipeline attacks, with United Healthcare attacks. There have been a lot of really notable ransomware events. And I was looking at a really interesting study the other day that University of California, San Diego put out on what actually happens to the patients if a hospital gets ransomware. And so they were looking at incidence rates of cardiac arrest in the surrounding hospitals. And of course, if there's a full ransomware attack in a hospital, they effectively have to shut down. Patient care can't happen, administrative tasks can't happen, reimbursement doesn't happen. Nothing happens when everything gets ransomwared. So they have to send all their patients to other hospitals. And they noticed even outside of just, standard influx of a larger quantity of patients, there was an 80% uptick in cardiac arrest rates and a significantly reduced survival rate for these cardiac arrest events, all because of ransomware attacks. And so it's a real problem. It's not just a conceptual issue. Of course, cybersecurity is relevant in every industry, but seeing cybersecurity in the financial sector, of course, nobody's going to want to lose their money and there can be major risk there, but it's unlikely that someone's going to die directly as a result of that cybersecurity attack, where major harm or even death is a very real possibility in this space.
100%. And, another example of this that we had where, defibrillators, implantables that were really easy to hack, this was years back. Examples of that are abundant. We, in the cybersecurity space, we're very familiar with the DDoS term, the denial of service term. And what, we need to fully acknowledge in a safety critical system, particularly medical devices, denial of service attack results in denial of healthcare service. And so you're going to have patients that are going to be denied healthcare, which could be time sensitive, which could be life saving if I'm going to put it under the DDoS, but any kind of attack that results in lost service actually succeeds on a medical system.
There was not too long ago an attack against a transfusion center in the UK under the NHS. And they were completely shut down. They got ransomed. They refused to pay the ransom. The attackers refused to give up. And so for several weeks, they were unable to administer any care. And this was often to late stage cancer patients who were down to a matter of months or weeks. And they weren't able to get any treatments. And so people were dying pretty quickly due to the fact that they couldn't get their treatment for an obviously extremely fast and dangerous disease. And so yeah, it goes to show that's that denial of care. And even branching outside of denial of care, we typically look at the CIA triad in cybersecurity: confidentiality, integrity, availability. The confidentiality, that's going to branch a little bit more into the HIPAA side of things. Nobody wants their, health records to be disclosed. And so finding a way to protect health information is critical. But I think integrity is something that can often be a little bit overlooked, and it's really important in this space. You look at a diagnostic system. If you're able to trigger a misdiagnosis in, either a false negative or a false positive, then can be pretty dangerous. If you say, yes, 100% this patient has cancer. Yes, they have cancer. Yes, they have cancer. And you're able to keep reproducing that effect, the doctor might prescribe them with chemotherapy and radiation treatments, which are obviously extremely, extremely hard on you, even if you do have cancer, and not very good for you if you don't have cancer. In the inverse, if someone has a very time-sensitive problem, like let's say we're trying to chase a sepsis diagnosis, and we're able to say that this is not septic tissue, and continually say this is not septic tissue, they're not going to get the treatment they need, and that could be down to a matter of hours that they have to survive.
100%. Yeah, and what you're talking about is something we usually capture in the risk management file. For every standard in regular quality management system for safety, there's also a standard that is parallel in cybersecurity. So, we talk about 81001, it kind of maps to 6304 in terms of just being kind of a total lifecycle approach to cybersecurity. We talk about 14971, it is basically just a risk management framework. There's a parallel framework in the NIST standard, but just threat modeling as a whole is basically what 14971 asks for in terms of risk identification and analysis and control. And so what you just said would typically translate to delay in treatment or, over treatment. That is basically how we capture that in the risk management file, which every manufacturer is required. This is now in the text of even 14971. They even redefined, they changed the definition of harm and risk in 14971 in the 2019 update. But you are also required to make sure you trace any cybersecurity, risk that you identify to the safety risk, and, vice versa, back and forth. 100% what you're saying then is something that a medical device manufacturer should already be capturing in their risk process, in their risk management process, in their risk management file. So when I think about the harm of overtreatment or mistreatment or delaying treatment, there's going to be a number of hazardous situations that could lead to that. And I'm using 14971 terms now. But those hazardous situations could include a cybersecurity attack if successful.
100%. Yeah, and that back and forth between the two. I know in the current FDA guidance, they like to see AMI TIR 57 as sort of that security risk management approach. And you read through that one, you read through ISO 14971, and they're very, very similar. I mean, there's almost like 70-80% overlap between the two. And they talk about where you're sliding from one side into another because they're so closely related. Cybersecurity risks can easily translate into safety and vice versa. One thing you mentioned, the update to 14971, and I think another very key point of that is their view on probabilistic scoring of a risk, which is something that the FDA explicitly says you cannot do at all. You can't use probabilistic measures. And instead, you want to move towards the exploitability factors, which are becoming a bit more industry standard. And so really objectively, how does this happen? Do you need credentials to do this? Do you need to touch the device? Can you do it? Can you attack a hospital in New York from Kansas? What level of access do you need to get? How complex is this attack? Do you need to attack the person or attack the device? And so all of those play into making things a little bit easier to follow as far as a risk management approach. I think it's, a little bit less subjective. We always going with a probabilistic approach. It's pretty easy to see two assessors argue about who's correct. They say, I think it's 1 in 1,000. Well, I think it's 1 in 10,000. And, who's to say who's right? There's no evidence behind it. Anyone can just try to make their point. So I think this shift, moving from that update in 2019 is it's a good direction for the industry in general to be following.
No, 100%. So, 14971, when it came to probability assessment, left it a little higher level in that it talked about the concepts of P1, P2, P1 being the likelihood of a hazardous situation happening, and P2 being the likelihood of the hazardous situation leading to harm. So, P1 would be cybersecurity breach happening successfully, and P2, that cybersecurity breach leading to some sort of a harm. This, understandably, did not completely apply to cybersecurity in the sense that it did apply. However, fundamentally, there's a difference between safety risk assessment and cybersecurity in the sense that with safety, we are not thinking, at least the majority of the time, about an intentional bad actor trying to, harm a particular device manufacturer. We're often thinking about, for example, when we do a DFMEA, we're talking about passive failures in the design, passive failures, unintentional misuse, for example, in usability. What happens if someone, makes a mistake in the PFMEA in the process of manufacturing a product. And so we are not thinking about someone intent to cause harm. We're talking about, just passive unintentional failures. And so this was recognized, by the way, before the FDA put out this guidance. Even in, the NIST framework, we had two likelihoods that would essentially have to work together to lead to P1, which would be, the likelihood of exploitation and likelihood of success. So likelihood of the attack happening, how lucrative is this for someone to even try? And likelihood of this attack, if happening, succeeding. Because, you've got a range of a spectrum of bad actors or, hackers who would attempt something lucrative, but obviously, it ranges from, what we call script kiddies all the way to, state-sponsored actors who are very methodical and abundant in resources. And so the question becomes, how far, does your security, essentially, like if your security is moat around the castle, can you just handle, bows and arrows or, catapults or missiles? What is it that your cybersecurity castle can handle? And so this is why the FDA decided, the 14971, the P1 model just wasn't enough by itself. We need to actually deep dive and talk about why do you think the likelihood of this is acceptable?
Definitely. Yeah, you bring up a really interesting point on how lucrative an attack can be. I think one thing that is a little bit of a misconception as far as cybersecurity risk is a lot of people say, well, who would do a targeted attack against this device? And the answer is probably not that many people. Like, truth be told, we don't really see targeted attacks against a specific device to cause harm. Um, Frankly, hacking's not easy, and it's a very small scale, like terrorist effort would be really the only thing that would lead to that risk. Really, what the main risk is just non-targeted, just prolific attacks, trying to spread ransomware through an entire network, and you never want to be the weakest link in the chain. And so I feel like that's a little bit of that's something that can just be a bit of a misconception is, oh, who's actually doing this attack? Because you're not making money from attacking just a single person unless you're trying to ransom them. And then you're trying to ransom everyone because, you're looking for it. And the way that threat actors are typically operating, not at the nation state level, that's usually going to be a lot more directed, but ransomware gangs, these hackers out of Russia and China and wherever else, they're usually just looking for the lowest hanging fruit. They're looking for someone left their password out online, severely misconfigured VPN, whatever they can find, just the quickest, easiest cash grab. They want to make their hourly rate as good as they possibly can. And so, it seems weird to say, but you don't really have to be perfectly secure. You don't have to be trying to defend against that nation state level threat actor who's trying to do anything he can to get into this product. That's not the use case we're looking at. We are looking at non-prolific attacks, just trying to look for anything to grab onto, and we have to be smarter than them.
100%. And I agree that that's the most common. I mean, there might be like specific scenarios, and not that one I can think of right now, but there might be specific scenarios where you decide when you do, for example, an asset-driven threat model, that you decide that your asset is of the kind that a state-sponsored, hacker might actually be interested in. But this is exactly why you need to put the framework of risk analysis in place and account for that particular line item. I do agree, Trevor. I think the most common category of risks we see for medical devices in practice is you don't want to be, the weakest, link in the chain. You don't want to be passively compromised with ransomware. And I think the other thing we do see is stealing of health information, because that can be sold and that can be also, monetized. That's the other part of this. So in terms of, anonymity, security protections, that has also been another lucrative asset that medical device manufacturers often have. But yes, 100%, it is rare that, a powerful actor targets one particular medical device, intentionally trying to compromise it.
Now, one interesting story. So Dick Cheney had a pacemaker, and we've talked about the story a couple of times. So I think it's really fascinating. He started to get really concerned and paranoid that someone could remotely hack into his pacemaker and potentially kill him. And it went to the point where he ended up getting it entirely removed. I think it was Patriot Act. They did an episode on it. Some show like that. I can't remember the name, but it was a big concern of his. And then there was, a proven trial. There was like a proof of concept against it. It wasn't done against, it never happened against someone in an actual live environment, as far as anyone's aware of. But they were able to prove that up to a kilometer away, someone could hijack that pacemaker with a very, very targeted, I think they called it a blue sniper. It was this very, very targeted Bluetooth. It looked like a gun, and they could aim it, very, very precise, very narrow beam. And it was effective up to a kilometer in range. And so that is another example where a political assassination could become a concern. Compromising 100%. An infusion pump or a pacemaker is obviously going to be far less conspicuous than any other method that could go down that path. And so I think that is a scenario where we could see some targeted attacks. Obviously we don't see too many attacks like that happening, but it has been a concern.
No, 100%. Building on my previous point, I don't think, being Dick Cheney is something that every manufacturer has to build into their risk management file. But Dick Cheney probably wants to build it into his personal risk management file. I feel like that's kind of one of those specific cases that we talked about. And you're absolutely correct. There could be individual cases that, given a special set of circumstances, warrant a state-sponsored actor to chase ultimate successful attack. It's just that's just not the prevalent scenario with the average medical device manufacturer, right?
Totally. But even looking at saying, well, that's part of Dick Cheney's risk profile. And so he's going to want to make sure that he has a safe product. What does the manufacturer have to do to ensure that they're building a quality product? What artifacts do they need to prepare? What do they have as far as their labeling that they're turning over to the end users? How are they handling acquisition to ensure, hospitals are pretty strict about what products they're bringing in. Attack against the hospital is going to be severely detrimental to them. So they don't want to expose themselves to risk. And so, yeah, it's not something that necessarily you'll have to consider as far as the risk to the manufacturer. They aren't going to have to think about, we have to consider this being in Dick Cheney or something. But they do have to consider, well, how are we making sure that whoever buys this isn't concerned about safety? And if they do have these security questions, how are we going to answer them? And I think that's where it ties into having that quality system in place, ensuring that you're building it out right the first time, and everything is well structured and well organized in a way where when these hard questions come up, you have the answers.
Yeah, 100%. I think at the end of the day, the FDA recognizes that cybersecurity is a shared responsibility of the manufacturer, the end user, even the patient, depending on, what the intended use and indications for use are. And so there is an understanding that not every potential scenario could be controlled against, at the manufacturer level. To your point, though, it is expected that you have a reasonable posture, but also that your posture enables the other, stakeholders who share the responsibility of cybersecurity with you. Most commonly a clinical system or a hospital system that you're getting integrated into, to then, for their own use case, add on top of your cybersecurity posture whatever it is they need to do. You see this thought process, evident across the entire guidances that FDA has provided. The SBOM is, a very visible example of that. The point of the SBOM is to enable users of your product to be able to adequately respond to attacks, vulnerabilities, and be able to then, for themselves, develop procedures around your medical device. And so 100%, I think this idea that, you need to protect against absolutely any kind of medical device cybersecurity attack is just not realistic. And, the regulators realize that as well.
Awesome. Well, we're coming up on time here. At the end of each episode, we like to sort of summarize everything with a couple words of wisdom. So I'd love to hear, what are your thoughts if you had to summarize what early stage manufacturers need to be aware of? What are the key kind of quick steps for their quality system, and how are they going to avoid some of the common pitfalls?
Yeah, absolutely. I think we often talk about, with quality and security, being thought of too late and therefore costing too much in the long run. And so, we are kind of myopic in the role that they play in the product development process. At the end of the day, you hear the concept of shift left often. Shifting left, meaning involve stakeholders early on. There is a question of how early is too early. And so I think it's worth talking about that a little bit. At the end of the day, there is a phase very early on in a product development process where your concept is changing too often. Your architecture is, evolving. You've got iterations happening to the point of thinking about threat modeling, thinking about quality assessment and risk management would be inefficient because your inputs keep changing to that. But there needs to be an understanding early on that there needs to be a line in the sand where we say, okay, we think we've got feasibility down. We know where we're going at the high level. This is not changing too much anymore. And at that point, think about quality management system, cybersecurity. I talked about regulations, product design, and the geography playing a role in setting the bar. One other thing, that kind of relates to all of that is just the management's position on how they want to bring the product to market. Because when you think about quality and security in terms of a positioning statement, your product may only have quality and security at the level required to sell in the market, which is the first three things that I talked about. But you may also want to position yourself, and this is what, an easy example to think about is Apple. Your security and quality end up being also your differentiating advantage that you sell on and you charge a premium for. Because at that point, what you need to do is set your quality objectives around cybersecurity to not just meet the first three, but also whatever it is required for you to stand out in the market. And so drawing the line on when we're going to figure that out is extremely important, and then sticking to that, because these projects are months-long projects, and if you bring people in too late, you're going to have a lot of rework and you're going to have a lot of cost.
Completely agree. Yeah, typically I always say that cybersecurity should be addressed early and often, and quality should be addressed early and often. Quality and cybersecurity are super, super tied together, like you keep saying. And I think that cybersecurity is just evidence of a quality product. So awesome. Well, it's been fantastic to have you on the podcast today, Ashkon. And thank you so much.
Absolutely. Same here. Thanks for having me, Trevor. And we'll be talking soon, I'm sure.